Okay, today we're going to discuss all of the pins and the layout of the board of the Arduino Uno. Just to get you familiar with some quick concepts, I'm going to be fast. We don't want to waste much time on this. So let's start with our digital input-output pins, which is pins 0 here through 13. So as an input, you can read if the pin is at 5 volts or 0 volts. There is a tolerance on there. I don't remember what it is, but generally speaking, it's 0 volts or 5 volts. You can also use them as an output to output 0 or 5 volts. So it will put output input or output 5 volts, and that's what these pins are used for. Pretty basic. The serial TTL port here of RX, TX 0 and 1. I recommend staying away from these because it can mess up with your programming when you're trying to program through the USB cable. You have to, or any communication when you write to the serial monitor. So until you understand what's going on, it's just best to stay away from those 2 pins there. Some boards like the Arduino Mega would have 3, I think, of these. So it wouldn't matter if you could plug into one that isn't being used, but in this board, just stay away from it until you, like I said, understand what's going on. Okay, so let's go to these pins here. The ones with the little squigglies underneath them are pulse wave modulation, which is just a fancy way of saying that we're going to be taking the voltage and we're going to put 0 volts, 5 volts, 0 volts, 5 volts, and we're going to be switching up and down really fast to create a simulated voltage. So let's say you were at 0 volts for a fraction of a second, and then at 5 volts for a fraction of a second, and you keep switching it at that speed, and you did that 50% of the time, you could make something think it's 2.5 volts. But we'll get into that in later detail later down the road. It may sound complicated, but it's not. So we'll get into that later. The one-wire protocol can be run on any of these 13 pins, and I believe even on these pins here, though I don't recommend using the Arduino or the analog pins here. So you can use that there, but we'll get into the one-wire protocol later. Now, pins 13, 12, and 11 can be used for SPI communication. So the SPI on SPI is pin 13 is the serial clock line, pin 12 is the MISO, and the pin 11 is MOSI. Now the SPI will also need one other pin to run to tell that device whether it's communicating, or more if you're, depending how you have it set up. But you can use any of those other pins for that. But we'll get into the SPI programming later. It's a form of communication to communicate with other boards or chips. Here's the ground pin. So the ground pin is right here. That's pretty basic there. A reference, analog reference, so you can supply, say, 3.3 volts into here, and then for analog reference, so the board can use it for comparison. But we'll get into that at a later date. Over here we have I squared C. You may see something that you might come across something that says I2C. The correct pronunciation is I squared C. It's another protocol for communicating with other chips and boards, and it uses the serial clock line here and the serial data line here. It's just it just has 2 wires on it, and that's all you need for that type of protocol. Okay, now over here is your reset pin, so you just hit reset and it restarts executing your code from the beginning, or just as if you had powered it on, which is pretty basic. Here's your USB plug-in, so you can use the USB plug-in to program the board and so forth and so on, which is probably your most common system. It is going to be the most common system you're using off the beginning. And it'll supply power to the board too, so you don't need to worry about supplying power as long as the USB is plugged in. If you want to supply power to the board and not have the USB plugged in because you want to test something, you can plug in a barrel jack into here and with a transformer, and it will power the board for what you need. If you don't want to use the barrel jack, on the power rail over here you have V in. You can supply 5 volts to that and it'll power the board too. Then obviously your 2 ground pins, 5 volts, and this is an output, so you can put out 5 volts out here. So it's different than VIN, because VIN is where the voltage is coming in, 5 volts is where it's coming out. Now this little board has a 3.3 voltage regulator on it, and this 3.3 volts can come out here, and you can use that to power certain different things. I'm not sure the current specifications on this board, I'd have to double check, but you can find it quite quickly from Googling it. They're very good about that. This one here, we'll skip the reset pin for a second. 5 volts over here, once again supplying power. The reset pin, which is RES here marked on this one, if you keep it high, it won't reset your board, and then when you ground it, it will. You usually use a pull-up resistor for that. Don't actually supply directly 5 volts to it, but we'll get into that later down the road. Over here we have analog in. So analog in is where we can read a voltage of between 0 and 5 volts, because this board is based on 5 volts. So if we have something, a battery, say it's 2.5 volts, it would take a reading, and the reading is between 0 and 1023. So if it was 2.5 volts, it would be half, which would be 511 or 512, one of those two numbers. I'd have to do the math on it. And if it was 1/4, it would be 1/4 of 1023. So we'll just get into that later, but you can be used for that. Now on these pins can be used for digital input and output. So they can be used for the same purposes as these pins, except for the pulse wave modulation. They can be used for that. So the only thing I recommend is if you're putting anything on here, don't put on a protocol like one wire or something like that, a high switching protocol, because it can mess up your analog readings. Say if you've got a battery hooked up to here and you're reading the voltage, and then you go and put a high switching speed communication protocol on here, it'll mess with your readings. I've had that problem before, so just bear that in mind. Over here we have the ISCP header. It's used to program the board. Obviously you can program through your USB port, but this is another way. You can use a Mark II. You plug it in and then you can just program it through here. This gets to be a lot more useful when you start to move your microchip off board, say onto a printed circuit board or something like that, because you obviously can just program this through the USB. But a lot of people swear that the Mark II is a lot better, but that's neither here nor there. Okay, well, so that kind of covers the board in general. If you have any questions or comments, just leave them in the margins and I will read them, and we'll get back to that from there. Thank you very much and have a good day. Bye-bye.